Hello everyone, today we're going to look at usaco-training Stringsobits. Okay, so in this problem we can consider an ordered set S of strings n, or each string has n bits, and bits are either 0 or 1. And it becomes interesting if it is ordered and it contains all possible strings of length n that have L or fewer bits. Or L fewer bits that are 1, I meant. So our task is to basically find the ith element of the set of strings. Okay, so again, the set is defined here, where the set or each string in the set has to be length n, and it may have no more than L bits that are 1s. So for example, we can be given a set with where each string has length 5 and each string has less than or equal to 1 bits, and we want the 19th element. And we just print a single line containing the ith element from the set. Okay. So we can actually consider how many ways, or let's consider a simpler problem where we're just supposed to find the number of items that are in the set. So we're given n bits. Okay, so let's just say we have 5, so we have n equals 5. And we also have, for the sample, we have L equals 3. So we have 1, 2, 3, 4, 5 nodes. Okay, so let's just say that the L condition does not matter. And this means that we have a total, in this case, we have a total of 2 to the 5, which would be equal to 32 possible strings, because if the L does not matter, then each of these bits would have two choices to be either 1 or 0. But then now we need to consider that L is 3 in this case. Well, what we can do is that we can actually apply binomial coefficients to this. So then, okay, so that's one case, and then we also have, okay, so we have n equals 5 and L equals 3. So then we know that there's 5 choose 0 ways to choose 0 bits, and we also have 5 choose 1 ways to choose 1 bit, and 5 choose 2 ways to choose 2 bits out of the 5, and 5 choose 3 bits, my bad. 5 choose 3 bits on how to choose 3 bits from this 5. So then, if we sum this up, this would get us the basically the number of ways, or total number of ways, or total number of strings in the set. Because we know that each string has 5 bits, because above here we know that we're choosing each 1 bit from these 5 bits, and then we make sure that it has no more than 3 bits, because each time we are either choosing 0, 1, 2, or 3. And all these 1 bits are not, or since 3 is less than or equal to 3, this would make sense. Okay, but now basically, since we actually want to get the ith element, not the size of the set, what we can do is that we can just create another array that stores this. So we can call this number. So number of ij would be equal to the total number of strings with length I that has no more than J1 bits. So then, as we have above here, we know that number of n of L would be equal to the equation we have above, which is 5, or basically it will be equal to n choose 0 plus n choose 1 plus n choose 2 until plus n choose L. So you know that this is number of L, but what we can do is that we can actually because this is basically our formula, because then let's use this. So number of ij will be equal to, again, you can take 0 bits, you can also take 1 bit, you can also take 2 bits, and you can also take j bits. And notice that you cannot take j plus 1 bits because this would not fit the conditions we have here. So actually, 1 second, let's actually expand this paper. Okay. Alright, so now that we have this, or this quantity, or the number of ways to create, or number of elements in our set, we can actually use this to find our answer. So as above, we have n equals 5, L equals 3, and we want the 19th element. Okay. So, again, we can consider that we have 1, 2, 3, 4, 5 zeros. Or, 5 bits, not just 5 zeros. Okay, so now we can basically start off at the top where we calculate the value of this bit. Okay, so we know how to, so it's right over here. So we know the number, okay. So we know the number of ways to choose to have 4 bits with the maximum number of ones would be 3. So we know this quantity. So now this quantity is basically equal to the number of ways to assign these values if this value is 0. Or basically, what I mean is that if this value is equal to 0, so if this is equal to 0, then you know that there's basically num for 3 ways to of elements in this set, because if we choose 0, then it means that we still have L1s, so which means that we still have 3 ones to choose, and we have 4 positions, so this would basically equal to num for 3. So now what we can do is that we can compare I with num for 3. Okay, so then num for 3 in this case would be equal to 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3. Should be equal to, you have 1 way choosing nothing, 4, 6, 4. And this would result in 15. Okay, so you know that you have 15 ways to choose this, such that the ones, or the number of ones in this 4-bit string would be less than or equal to 3. But you notice that 15 is less than the 19 you have here. And this means that this bit has to be 1. Because if this was 0, then it means that you have exactly 15 ways to go on the other side, or on here. So then it means that if this is 1, then this string would be greater than well, let's actually explain it better. My bad. Okay. So basically we know that we have Okay, so we have 15 ways. We have 15 ways. If this was 0. So if this was 1, then this string, then no matter what we have here, is going to be greater than whatever number of strings we have, or whatever 15 strings we have. And this is because if this bit is 1, then it means that no matter what we have here, let's just say even if it's 1, 1, 1, 1, then this would be 1 plus 2 plus 4 plus 8, which would be 15, would not be greater than 16. Okay. So then, what we're going to do is that we're going to, whoops. Okay, so we're going to compare this 15. Whoops, okay. We're going to compare this 15. My bad. Okay, we're going to compare this 15 and our 18. And then we see our 18 is greater or equal to this. So then we assign this a 1. And then again, we know that we're done with this bit. So then we're going to subtract. So we're just going to subtract 15 from 18. So then our L, or our I actually, this would become, whoops, I mean this is actually 19. So this would become 4. Because we know that we're basically expending all those 15 possible strings. So now we're done with our first value. Okay, so let's actually erase this. Alright. So now we're going to calculate the value for this. So we're calculating this. And again, we can consider this portion. Okay, so since we already used a 1 over here, then it means that we're actually left with 2 1s. So then, again, we see that we have num 3, 2 ways to have a string over here if this bit is 0. Okay, so we see that this would be equal to 3 0, 3 1, 3 2 would be equal to 1 plus 3 plus 3, and this would be equal to 7. And that 7 is greater than 4, or yeah, it's greater than 4. So this means that this bit must be a 0. This is because that if this is 0, then you have 7 ways to do it in here. And since we're actually on our fourth one, and fourth is less than 7, then this means that the string would lie in here. Okay, so now we just did another bit, and let's just proceed with the next bit as well. Alright, so now we're doing it this bit. Let's actually erase this as well. Oops. Alright, so again, we take a look at this suffix of this string. So then again, you know that you have 2 more left, and then you have 2 spaces. So then again, you take num, since we have 2, and we can put almost 2 bits. Okay, and this would be equal to 2 choose 0, 2 choose 1, plus 2 choose 2. This would be equal to 1 plus 2 plus 1, which would be equal to 4. Oops, okay, 4. And then you see that and then you compare this 4 to this 4, and this 4 is actually corresponding to I, so I equals 4. And since 4 is basically equal to this, so this means that this bit has to be a 0, because we only take this bit if I is greater than our num I j. So again, we put this bit at 0. We take our next one. Okay. So let's erase this. Proceed to our next bit. All right. And then, okay, so now what we actually have 2 bits, and we have 1 place. So again, we take num 1, 2. This would be equal to 1 choose 0, 1 choose 2. 1 choose 1. And this would actually result in 2 because you have one way of choosing this and that. So then you see that 2, it's actually over here, 2 is less than 4. So then now you know that we must take this bit. Okay, so we're going to take this bit, and our number would become 4 minus 2, which would be equal to 4 minus 2 would be equal to 2. Okay, so now we have that bit. We're going to proceed again to our last bit, or finally our last bit. Okay. So now for our last bit, again, we're seeing nothing. So now what we're going to do is that we have num 0, and we actually, oh yeah, so basically since we used a 1 over here, our 2 would become a 1. So then this would be 1. This would be equal to, this would be equal to 0 choose 0, which would be equal to 1. And notice that what I said over here, this isn't exactly true because, or this is actually true because actually you could do plus 0 choose 1. And notice that you have 0 ways to choose 1 element out of 0 elements, since you don't have that many elements, so this would be equal to 1. So again, you see that I is equal to 2. Num ij will be equal to 1. Since this is greater, you're going to take it. And then ta-da, here is our string. So again, we just output it, and then that will just be our answer. Alright, so let's get to coding. This is actually easier to implement than to explain. Okay, so Stringsobits. Okay, so let's include studio. Okay. So we're going to be given a number n, l, and I. So we're going to have n, l, and I. So let's read this. Alright. So after this, we're going to start calculating. So since we actually want to use the binomial coefficients, we actually want to calculate that as well. Okay. So now let's call this coefficients. So we have a total of 32 bits. So let's actually use longs just to be safe. So we basically have 32 bits at most. All right. So we can actually do some dynamic programming again on this binomial coefficients. So we can have our I from 0 to 31, so 32. Alright. So then, basically, we want to choose j elements out of I. So what we can do is that there should actually be less than or equal to I, since you actually can't choose more elements than that. So if we're choosing 0 elements, so if j is equal to 0, then coefficients of ij, because you know that you have one way of choosing this. Otherwise, coefficients of ij will be equal to, okay, so now we're actually going to assume this. So let's just say we're taking the ith element. Then we're basically left with I minus 1, j minus 1. And we also can take, if we don't take this element, then it means that we're left with j elements. So notice that for I equals to 0, whoops, let's see, so coefficients, okay, that's weird. Okay, so it looks like I did define it, but, alright, whatever, but, okay, so notice that for I equals to 0, this would actually not work, so then we can actually make a case out of that. So we can actually take out 1 over here. So now we're going to calculate, basically how do you choose x element out of 0. So then we know that we have, or this is actually coefficients. Oh, this is coefficients. I did misspell that. Okay, so you know that you have one way of choosing 0 elements out of nothing. So then you have one way. Okay, so now we have that fixed. Okay, so now we're going to calculate basically the size of each ij. So this is, let's actually name this num. So this would be num 32, 32 again. Okay, so we're going to loop through each bit. All right. So now what we're going to do is that we're going to loop through. So I will be equal to or let's actually call this k. So we're going to loop through each element. So we're basically assuming, or actually, I can actually show you. So over here, I have that num ij will be equal to I0, I1, I2 until ij. So this is actually a sum series. So then over here, we can do k equals to 0. K has to be less than or equal to k, an increment. And then my number of ij, I'll just add this by, again, you can see my, okay, so it's going to be I choose k. So then over here, this would be I choose k. So now that we're done pre-computing our values, what we can have here is that we can basically start finding our answer. So then we know that we have n bits. Okay. So then now we're going to compare. So now we know that we want the ith element and we want the ith one. So then we know that, let's call this int x, or actually long. So x would be equal to the number of ways you can choose. Basically or let's actually do it like this. Alright. So we can actually, since we actually want to know how many bits we have right now, we can actually do this while n minus minus. Whoops. So then what this would do is that on the first recursion to here, we know that we're left with n minus 1. So this would be equal to num n, or actually this may be kind of confusing, so I'm just going to, for int I will be equal to n, meaning that we're doing the nth bit, since we're actually calculating this in reverse. So the x would be equal to I minus 1 because we're actually looking forward, and we're going to loop through. The L is going to be, we're assuming that this bit is going to be 0, so we're going to check this value. So then we know that if I is greater than x, this means that we're going to use a 1. So then we're just going to printf 1. And then we're going to subtract x from I. And then we're going to decrease the number of 1 bits we're left with, since we just used a 1. Otherwise, we just print 0 and just continue. So now over here, we just print a new line, since that is basically required by the grader. Okay, so this is Stringsobits. Let's actually run it. Alright, let me grab the input. Okay. Whoa, okay. Yeah, so over here, this should actually be minus, because we're actually looping backwards. Okay, so 10011, that looks good. So we're actually reading from Kimbits to N. Right. Alright, so this, just submit it. Alright, so let's look here. Alright, so this is going to be usaco-training and Stringsobits. One second. Alright, so let me actually reselect it. Alright, Stringsobits, I got it. Here we go. Ooh, okay. So it looks like we actually have a problem on the last bit. Interesting. So let's actually grab this case. And we can go ahead over here. We can run this. Actually, not yet, since... So this is actually basically off by 1. Alright. Okay, so... Interesting. It's printing all zeros. Wonder why? Oh, okay, so I kind of see. So basically, I is going to be kind of big. So then what we can do here, I guess this should be a long. This actually isn't working. Okay, so coefficients of I. So integer, and long. Oh yeah, so I guess maybe we should store L as well as a long, because I'm pretty sure, I'm not sure, but this may actually exceed the integer limit. Okay, yeah, so that looks good. Yeah, so I should have actually washed out, because the maximum element, which is 2147, 483648, is actually just one more than the maximum integer. So let's actually resubmit it. Alright. Okay, so that is right. If you have any questions, feel free to leave them in the comment section below. Bye.